Hey guys, welcome to another episode on my channel. So today we are going to talk about this SR04 distance detector. It works up to 4 meters distance. And actually how it works, it has 4 pins, one for ground, one for 5 volts. This is 5 volts model, and we have another 2 pins. I don't know, can you see it? Okay, you can. One it's named trigger, another it's named echo. Trigger it's output pin, echo it's input pin. Basically, when we send high signal on trigger, we are going to produce sound signal that is going to be sent towards the object. When that signal gets back to this sensor, our echo pin is going to get low, and we are going to measure that interval with our ESP8266 microcontroller, and then we are going to make calculation in order to produce a real number, meaning distance in centimeters. And of course, for this project we are going to use our microcontroller, our sensor, and some wires. And let me make this setup. So I'm going to plug this sensor in my breadboard. All right, I'm going to use a trigger pin, and I'm going to connect it to D5 pin on my ESP8266 echo. I'm going to connect it to D6, then 5 volts to plus, ground to breadboard, and now we are going to add 5 volts to our sensor and ground to ground. All right, now we are going to do coding. So guys, for this episode I'm going to use Visual Studio Code, but you are free to use any IDE that you like. So first thing that we are going to do now, we are going to declare these 2 pins, so D5 and echo on D6. Then we are going to initialize serial monitor with baud rate of 9600. Then we are going to set pin mode for these 2 pins. So our trigger is output, and then pin mode for echo, input. And now this is important part. First we are going to set digital value for trigger to low. Now delay in a microseconds, 5 microseconds delay. So why we are doing this? We are making pause before we send signal, and then we are going to make another pause after we send signal, in order to get signal clear as much as possible. And you could actually tweak these settings in order to get the best settings for your sensor. Because occasionally what could happen? If your microcontroller mixes signals, at the end you could get some crazy numbers with your calculation. So we want to avoid that as much as possible. So now digital write trigger high, and we are going to send a high signal for 10 microseconds, and then digital write for trigger low. Now I'm going to create one long variable, call it duration, and we are going to use function pulse in on echo pin for value high. Function pulse in is going to return value in microseconds for how long sound traveled to destination object and back. And based on that, we are going to calculate distance. So now long distance, so duration divided by 2. Because during entire duration, sound signal traveled to destination object and back, and we need only half of that value. And then we are going to multiply this by 0,0343. This is constant value in order to get result in centimeters. So finally, I am just going to print this out. Let's go with print ln, and we are going to print distance. All right, and I'm going to make delay of, let's say, 1 second. It's totally fine. Save it, build it, and now I'm going to upload this code to my microcontroller. Alright guys, now you can see my sensor, and I'm going to start my serial monitor in order to see what we are going to get. Okay, this sensor is directly in front of me, so these numbers are fine. Okay, I'm going to get closer with my hand. Let's see what we are going to get. Alright, this is cool. Okay, we have some junk data, but don't worry, that's usual. In some real-world example, you are going to take care about these crazy numbers. For this video, this is totally okay. So guys, thank you for watching. I hope that you like this content, so please like, subscribe, and see ya!